Hello, good morning, friends. Welcome to Vvsm Academy by Veerabhadraya. Karnataka State Syllabus Sslc 10th class Science Previous Question Papers March 2020 as well as 2021. Objective type questions and in-text questions and answers. Chapter 4 Carbon and its compounds. Inorganic carbon compounds. Well, friends, question number 1. What is carbon? What is the chemical symbol? Answer is carbon is a chemical element with atomic number 6. Its chemical symbol is C. You know, inorganic and organic carbon compounds. Inorganic compounds contains all the elements which reacts with carbon giving carbon compounds. But organic compounds, hydrocarbons are a special branch of chemistry we will study in the organic chemistry. So here organic chemistry as well as inorganic chemistry, in both the things carbon has got a predominant role in the inorganic chemistry as well as organic chemistry, my dear friends. Let us discuss about today. Write the structure of carbon atom. The structure of carbon atom. Atomic number is 6 and hence the 6 electrons and 6 neutrons and protons. Let us discuss about the inorganic carbon compounds. Write the structure of carbon compound means immediately you have to write the structure of carbon only. Structure of carbon is 6 protons and 6 neutrons. You see, these are the atomic structure of carbon or a dot structure of carbon. How many valence electrons are there in an atom of carbon? You know, my dear friends, there are 4 electrons are there in the outermost orbital. So therefore, the free electrons are called valence electrons and hence the tetravalency of carbon is established. An atom carbon contains 4 valence electrons. This means that an atom of carbon has 4 electrons in its outermost shell and hence the valency of carbon is 4. Hence the substitution reaction occurs in the organic chemistry. What kind of chemical bonds are present in most compounds of carbon? Generally, covalent bonds are present in most compounds of carbon because of the sharing of electrons forming covalent bonds. If the substitution reaction occurs, this we will study in your organic chemistry separately. This we will discuss. Generally, chlorine undergoes chemical reaction with the methane, gives the substitution reaction. Monochloromethane, dichloromethane, trichloromethane, tetrachloromethane, all the compounds are called substitution products. You know, this will study in the detail in the next class. Okay, what product is produced when carbon is burnt? In the inorganic chemistry, carbon undergoes combustion when it burns in oxygen. Charcoal, for example, gives carbon dioxide and heat. And carbon monoxide again combines with oxygen, gives carbon dioxide and heat. And methane and oxygen gives carbon dioxide and water. This is the water gas. This is the mixture of carbon monoxide and hydrogen is water gas. That is this is a different question. Okay, now state the properties of carbon compounds. Most carbon compounds are poor conductors of electricity. They have low melting point and boiling points compared to ionic compounds. Forces of attraction between molecules are not very strong. Therefore, bonding in these compounds does not give rise to any ions. But the special unique nature of carbon, for example, graphites, Graphite rods are good conductors of heat and electricity, and hence it is used in the industrial chemistry and all. So therefore, carbon, it is a extraordinary nature of carbon. Here, the most carbon compounds are poor conductors, but pure carbon is a very good conductor of heat and electricity, which are the best example is graphite rods used in industrial chemistry. You explained the importance of carbon in our life. Carbon is found everywhere in our life, my dear friends. The food that we eat contains carbon atoms and compounds of carbon. The fuels that we use have carbon atoms in them. The paper we use, the medicines we consume, the clothes we wear, and the soaps and detergents that we use every day-to-day life, plastics and polymers that we employ to meet our needs are all made up of carbon atoms. Day-to-day life we are using most of these one carbon atoms, the materials made up of carbon atoms. Life on Earth itself is a carbon-based. Carbon constitutes the most essential component of all living systems. It is impossible to think of life without carbon. So, carbon acts as a predominant role in our day-to-day life, my dear friends. How is carbon found in nature? You see, carbon is present in the atmosphere in the form of carbon dioxide, carbon monoxide, methane, etc. Carbon is found in the Earth's crust in the form of carbonates, bicarbonates. All living systems contain carbon in one form or the other. My dear friends, you see, and carbon dioxide is 0.4% in the carbon dioxide. And argon, this is the components. The main component of is nitrogen 78% and 21% oxygen in the atmosphere. Carbon dioxide is meteorologically is a very important gas. It is transparent to incoming solar radiation but opaque to the outgoing terrestrial radiation. It absorbs a part terrestrial radiation and reflects back some part of it towards the Earth's surface and is largely responsible for greenhouse effect. The volume of other gases is constant, but the volume of carbon dioxide has been rising in the past few decades, mainly because of the burning fossil fuels. This has also increased the temperature of the air and associated phenomena of global warming, found up to 90 kilometers from Earth's atmosphere. Question number 7. Most of the things we consume or use in our day-to-day life are made up of compounds of carbon. Explain this statement. If we make a list of all the things we consume or use in our day-to-day life, most of the things such as soaps, detergents, newspapers, books, furniture, food items, etc. are all made up of compounds of carbon, except metal objects and ceramics. Most other materials known to contain carbon compounds. This shows that the things are consumed or used are made up of compounds of carbon. Question number 8. What is the percentage of carbon dioxide in the Earth's atmosphere? What is the percentage of carbonates and bicarbonates in the Earth's crust? The atmosphere of the Earth contains carbon dioxide to the extent of 0.03%. Carbon is found in the Earth's crust in the form of carbonates and bicarbonate to the extent of 0.02%. Question number 14. Mention 3 special characteristics of carbon atom that are responsible for its innumerable compounds. The following are the reasons for the innumerable compounds of carbon. The tetravalency of carbon, that is, valency of carbon, is 4. Carbon has the ability to form bonds with its own atoms, forming a chain. Many compounds of carbon show isomerism. This we will discuss in our organic chemistry. Okay. Question number 15. Explain the tetravalency of carbon atom. The atomic number of carbon is 6. Its electronic configuration is 2 and 4. This means an atom carbon will have either lose 4 electrons or gain 4 electrons to attain the most stable configuration or stable structure. However, both these are difficult. Under extraordinary conditions, under drastic conditions, the reaction occurs to fulfill the tetravalency of carbon atom. Therefore, carbon atom overcomes the problem by sharing its 4 valence electrons with other atoms of carbon and atoms of other elements and attain stable structure or stable gas configuration. Since 4 valence electrons are shared, carbon is tetravalent. Tetra means 4. Question number 23. Draw the electron dot structure for the formation of a molecule of ammonia. Nitrogen has got its valency, variable valency, monovalent, divalent, trivalent, tetravalent, pentavalent. The nitrogen has got a variable valence state, valency state. So therefore, when nitrogen is having only one valency is 1, in the nitric oxide valency is 2, nitrous oxide valency is 3, nitrogen trioxide valency is 4, nitrogen tetroxide valency is 5, nitrogen pentachloride, etc. So these are the very important things. Now coming to this, explain the electron dot structure of methane. Methane is a CH4 formula. So carbon is having a tetravalency. When one electron sharing of with hydrogen, it is monochloromethane, dichloromethane, trichloromethane, and tetrachloromethane respectively. These are called substitution products. This will be discussed in the previous class. Thank you for listening, and this is Vsm Academy. If you like our video, please share, like and subscribe. Don't forget to press bell icon, my dear